Bright Duty. Every student matters.
Hello dear students, my name is Amit Ajmani and today we will be talking about force and laws of motion. Till now, you must have studied about motion. We have talked about the various aspects of motion. That is, how motion is produced, how body is moving. The motion was classified under uniform and non-uniform motion. But the thing which is very important to understand is what exactly causes motion, or if a body is already moving, what causes the body to stop. Now this is something which we need to relate. Why? Because the scientists have been thinking about this aspect right from the beginning, that what exactly is the driving force, what exactly is the thing that is causing a body which was initially at a stationary position to be in motion, or if it was in motion then to come to rest. We have observed many things around us, like if we hit something or we push something, then the body starts to get in motion, but after some time it stops. Now why does it stop? Fine, why is it stopping? Then the scientists thought that it was natural, that the rest position is the most natural state of a particular object. But Galileo and Newton, they changed this thought process altogether with their few experiments, and from there we get the concept of force, and from there we get the concepts of laws of motion, which we are going to study one by one. Alright. In our everyday life, we observe lot many things that we require some effort to put a body at rest which was stationary to be in motion, and if a body is basically in motion, then we basically see that it comes to rest after some time. Now to initiate motion, we see that we have either to push an object, or to pull an object, or to hit an object, right? So whenever we want to bring a body, a stationary body, a body at rest into motion, we have to either push it or pull it or hit it. Now let us see a few examples where we have created motion in a body with these things. For example, if we are talking about pushing any particular object, for example, we are pushing a trolley in order to make it in motion, right? Similarly, if we want to open a drawer, we need to pull the drawer or need to pull a refrigerator door, right? Or if we want to just bring a stationary hockey ball into motion, we have to hit it with a hockey stick. So we can say that in order to bring something in motion, we have to push or pull or hit. This pushing, this pulling and this hitting is basically known as force, right? So how can we define force? Force is defined as a push or a pull on an object, right? So pushing, pulling or hitting an object will bring that object into motion. Alright. Now when we talk about this pushing, pulling and hitting, then we just try to relate another aspects also. It is not only that by pushing or pulling or hitting we are just only bringing a stationary body into motion. It is that by applying this force, which we have never seen, we have never just experienced, it is I will not say that not experienced, it is basically which we have experienced or felt, right? I repeat, this force we have not seen. Nobody has seen what exactly is force, but we have experienced force, right? So this force, not only can it bring a stationary body into object, but it can also perform various functions. Now what are the impacts of force? Let us try to relate. The first impact of force is this force can move a stationary object. This is the first effect of force, that if a body is in a state of rest, by applying this force, it can come in motion. Second thing, it can change the speed or velocity of the object. It can change the speed, means it can change the way the body is moving. If the body is moving at a greater speed, on applying opposite force, it will slow down. Or if the body is moving slowly, then on applying force, it will speed up. Similarly, by applying force, we can also change the direction of the force, the direction of the object. Next thing, the effect of force is it can stop a moving body altogether, right? So these are the various effects of force that we see. Got it? Fine. Now, when we apply force on something, then this force is categorized into two types. One is balanced force and another is unbalanced force. Now, what exactly are these balanced and unbalanced forces? Let us try to explain with the help of an activity. What we'll do is, we'll just take a wooden block, right? We can just take it on a tabletop or on the floor anywhere, and we will attach two strings. One string is, let us name it X and Y. Fine. Now, if I pull this string X, then this particular wooden box is going to move in the right direction, right? Similarly, this is the first case when I have pulled the string X. I have applied force in this particular direction, so the wooden block is moving in this particular direction in which force is applied. If keeping X constant, I just pull the string Y, then we see that this wooden block will move in the left direction, that is in the direction of force, right? But if I pull X and Y at the same time with equal amount of force, then we see that the box basically stays, or this wooden block stays where it actually was. Now, this kind of force, these two forces, even though the forces are being applied, but they are actually nullifying each other's effect, and the resultant force on this wooden block is zero, because of which there is no motion, no movement, no displacement in this wooden block. These type of forces are known as balanced forces. These are equal and opposite forces. Equal and opposite, I mean to say that they are exerted in the opposite direction, because of which they cancel out the effect of each other, and these balanced forces, when they are applied on an object, because the resultant force is zero, therefore very importantly, there is no motion produced in the wooden block, right? Similarly, if there is a moving object, right? If there is a moving object and we apply these balanced forces, then in that case, the speed with which it was moving, it is going to continue uniformly with that particular speed. Why? Because balanced forces are acting on it, the resultant of which is zero. So ultimately there will be no effect or impact on the speed of that object whatsoever. So it will continue going at the same speed, right? So these are balanced forces, and the important thing is that they produce no motion in the object if the object is stationary, or they do not alter or change the speed if the object is in motion, right? Now, take another example, that I am applying force by pulling X as well as Y, but now I do not apply equal amounts of forces, right? Let us take an example that I apply X, more force on X and lesser force on Y. So in that case, now this force X is going to pull this particular wooden block in its own direction, and Y will be overcome by this force X, right? The force which was applied on string X. Fine. These kind of forces are known as unbalanced forces. When the forces may be opposite to each other, or rather in opposite direction to each other, but the total amount of force on both sides is not equal, due to which the more amount of force wherever it is applied, the object is going to move in that particular direction. These forces are known as unbalanced forces. Now, the impact of unbalanced force on a stationary object is that the body starts to move. The body moves if it was a stationary object, and if the body was already moving, then now there will be two unbalanced forces acting on it. One an unbalanced force, take a hypothetical example that one force is opposing, right, the speed, and one force is accelerating the speed of the object. Now if the opposing force is more, then the moving body will slow down, and if the accelerating force is more, then in that case the moving body is going to speed up. Fine. So whatever the situation is, the unbalanced forces always bring about a change in that movement or present position of the object. Like if the object was in state of rest, then it will start moving, and if the object was already moving, then its speed will be changed, right? It's a normal common observation when we see that we have to push a heavy box, right? If I am taking a heavy box and it is on the floor, a rough surface, any surface, if I want to push it, I want to just displace it from one position to another, of course I need to apply a force on it. Fine. Let us take an example that a child, he is trying to displace that particular box. Fine. Now when this box is kept on the floor, let us take this box. Now this box is kept on the floor. We know that whenever two surfaces are in contact with each other, they will always exert a frictional force, right? And that frictional force is always in the opposite direction, which tends to stop the movement of the object. So if a child is trying to push this box in this particular direction, he is applying some force. Now initially, if less amount of force is applied, now there are two forces acting on this particular box. One is the force of the child and another is the frictional force from the surface or the ground. Now if the ground frictional force is more and the force of the child is less, then in that case this box stays here only, right? So now the child increases his force, and now also if the force is less or equivalent to the frictional force, the box will not move. So in order to make the box move, we have to, or the child has to apply a force which is greater than that frictional force, because of which the box will now start moving. Got it? Another very common day example, that whenever we ride a bicycle, why it does not happen that I'll paddle up the bicycle 8 or 10 times, my bicycle is going to be in a particular speed and then it will go on, continue forever. Does it happen? Have you ever tried? Does it happen? Of course not. Why not? This is because of the same reason that the bicycle is moving on the road or a surface which basically imparts a frictional force. So if I will stop paddling, then consistently the frictional force is going to oppose the motion of my bicycle, because of which the bicycle will slow down and after some time it will come to rest. So if I want to keep moving, I need to keep paddling. Otherwise, the frictional force of the surface is going to stop me, is going to slow me down. Right? Now, whenever a particular balanced force is applied, balanced force, the forces which nullify each other's effect, the forces which are acted equal and opposite to each other, and they are producing no motion. So whenever a balanced force is acted on it, then there will be always, if the body is in motion, there will be always a uniform velocity of the object, until unless some other external force is applied on it. So if we want to change the velocity, the speed or the direction of the object, then we always have to apply unbalanced force.